This is a demonstration of my equation unifier Solidworks macro. I'm going to jump right into the demo, and after that I'll explain what's going on and why it's useful. I fired the macro and we see this initial message. The source model and its equations are listed in the first column, and the three columns on the right are each target model and the status of those equations in each model. So in all cases, the value matches, meaning the equation exists in the target model and the value is the same as the source model. So if we want to actually do something, we have to go into the equations of one of the models and make a change. I'll try changing the branch angle from 60 degrees to 45 degrees. I fire the macro again, and we have a new message. It recognizes that the branch angle is now 45 degrees in the source, and it will update in the targets if we proceed. We proceed, the macro cycles through each one of the parts, target models. It writes the new equation value to the target model, and it concludes by bringing us back to where we started at the source model, and we have a confirmation message. We can see the branch angle is now 45 degrees in all four models. The last thing we need to do is run the rebuild command to get the geometry to resolve, and there you have it. So what's going on? This is a Solidworks assembly composed of a trunk pipe, a branch pipe, and a weld. If we look in the section view, we can see that the branch pipe is beveled and the weld has to fill that bevel, right? So clearly these parts must share a lot of common geometry in order for that intersection to be correct. Solidworks provides a out-of-the-box way of doing this, but it involves creating an external reference from one part to another. And that has the pro of making it so you can change the geometry in one place and it'll update in the other part. But the downside is that those two parts are now linked, and the one part that relies on or references another cannot resolve unless the part upon which it relies is opened. And in a production environment, it's highly advantageous to have every one of your parts and assemblies be entirely standalone. It puts a lot of robustness in your models, and robustness is always beneficial. Okay, let's look into some more detail about what's going on. What if we create a new part? Of course, if we do, the new part has nothing, it has no equations at all. What do we have? Part 6. So if we run the macro in part 6, we see this message, something went wrong. Part 6 must have an equation in the following format, EQ key equals value. And it explains what that means and it explains how it works. So basically, let's go back to one of our other enabled models, look at its equations. Here are the equations that we're actually sending from here to here, from here to here. These are the equations that we're sending back and forth. And here's that EQ key equation. The EQ key equation acts as kind of like a broadcast channel. So whatever the value is, this macro will operate on any other models that have that same value, right? Now it's important while we're here looking at this to recognize that there's a bunch of other equations, and these are sketch equations. This macro doesn't operate on them at all. If it did, that'd be a bad thing. It would generally break your models, right? So it only operates on the global variable equations. Okay, so we've got to go back to our new part 6, and we need to manually add EQ key equals 1. And now, of course, if we try to send equations from here, nothing will happen because there are no global variable equations to send. We've got to go back to one of our other models that has some. If we fire the macro from here, now we can see our new part 6, and its status is new, meaning these equations don't exist in part 6. We already knew that. If I proceed, part 6 is now part of the EQ key equals 1 club, and so it will receive all of the equations from any other model that is operating on that same EQ key equals 1 channel. So success. So now we have a total of 5 parts in the club. The last thing I should mention is that at every stage there's a ton of debug info that's copied to the clipboard. This should kind of put your mind at ease. If anything gets messed up, you always have kind of a fallback. It'll list all of the equations before the edit and all of the equations after the edit. Thanks so much for watching.